In this segment, it's going to be a continuation of last month's segment on serial communications. Now, if you missed last month's, I'll do a quick recap, and you'll have to go back and really pay attention. So, serial communication is really a simplex communication layer that's usually over two wires, minimal of two wires. You have signal and receive, and usually a common ground between your equipment, so you have a common layer of communication. Now, of course, there are three primary voltage levels, which I've covered in the previous episode. In this segment, those three levels will be TTL, which are 3.3 volt logic, CMOS, which is 5 volt logic, or RS-232 levels, which is 12 volt logic. Depending on what your hardware wants will determine which protocol you will use. And then there's the underlying actual software communication layer. There are different communication layers such as ANSI or ASCII. There's also X modem, Y modem, and Z modem, file transfer protocols. We'll get into a little bit of that later. And there's also level converters. What happens if you have a 3.3 volt logic system that needs to interface into a CMOS 5 volt or an RS-232 12 volt system? That's what we're going to get into today. We're going to get a little bit into the level converters and more into the software. This is going to focus mainly on the actual mix between hardware and software itself. So let me re-angle the camera, show you some of the hardware that we're going to be playing with today, and then we're going to get to the software side and we're going to show you how to have fun with the hardware. Over here we have a Max 232 CPE chip. I actually had the schematic in the last episode. I'll put it up again real quick for everyone. Basically what this is an actual TTL to CMOS and RS-232 line converter. This chip just has a couple of capacitors that are used for charge pump as well as voltage coupling, and I've got an LM7805 voltage regulator hooked into a 9 volt battery clip. To interface into the actual hardware, I used stereotypical pin headers, same things that you use to hook up the LEDs and power switch to your computer. This all actually will output to a headphone jack. Reason being is because this is a very simple null modem configuration, meaning that it does not require data carrier detect, data terminal ready, data set ready. I'll try to get a nice zoom in of this header right here. As you noticed, with this actual header, I've actually jumpered a few pads. These pads are jumpered in a null modem configuration. If you notice that pin 1, pin 5, and I do believe pin 6 are all jumpered together, as well as pins 7 and 8. So these pins together will actually fool a standard typical PC into thinking that the machine or the computer on the other end is ready to receive and transmit data. And then these three lines, red, green, and black, being receive, transmit, and ground. And I used a regular headphone jack, typical 1/8 headphone jack, nothing special about it. 3 pins. You have your ground, receive, and transmit. You can wire this up in any fashion that you like. Over here in my hand, I actually have what I call a null modem gender bender. We've got a male and a female on the other end. It's wired up in the same fashion, however, just different connectors. We've wired this up in the typical null modem fashion, where there's a common ground. Transmit and receive are actually 69ing, so the transmit on this side, if you notice at the red over here, is actually leading to the receive over here. So this is receive on this end, is transmit over here, and transmit over here is actually receive over here. So you're literally just crossing the transmit and receive lines, as well as this black wire, which is common ground. We're jumpering the appropriate pins on the actual connector itself, so the data terminal equipment itself thinks that the machine on the other end is actually up and ready to go. What you are seeing here is actually a rewired FTDI 232 controller. What I like about this chipset that is it does all of the level voltage converting all for you. You don't need to do any of the Max 232 or the Max 3232 level conversions. There are other forms of level converters that you can use, but the Max 232 and 3232 are the main chips to be using if you're using any kind of serial communications. This actually used to come out of an old, I think, cell phone or amateur radio programming cable. If you notice, all I really did was interface a whole bunch of little wires into the standard 9-pin serial communication port, revamped the USB cable, and I put on a transmit and receive LED, although I haven't hooked those up yet. It's not the prettiest job in the world, and I've encased the entire thing in an Altoids tin, relatively so there's no radio interference on the outside world. This is what we're going to actually be working with today because it actually works really well. Now, I do actually have a prolific standard $8 USB to serial adapter, but the main problem with this is it doesn't do the level converting as well as I'd like, and it's a bit bitchy to work with. So, we've also got a WRT54 GL. Of course, I've done some mods to it. As you notice right here, I've actually got a couple of modifications. This is actually the dual serial port header. Most WRT54G, GL, and GS's come with an onboard serial port. Some have the headers in place, some do not. If you go back a couple of episodes to my Salvaging Electronics with a heat gun segment, yeah, you'll be able to go and find the available components to put this header back in place, and then if you can run DD or Open WRT, which will be a later segment, you'll be able to actually communicate with this port to create yourself a very, very naughty little device. Let's go to the software side and communicate with the WRT54GL via serial. Before we begin, the serial port adapter, 9-pin serial. This has been hooked up in the typical null modem 3-wire configuration and has just been jumpered to the board using the same type of jumpers I used on my Max 232 kit, which are the exact same jumpers that you find inside your PC for the LED and hard drive and all that jazz. So there's really nothing special to this. I'll just zoom out real quick and I'll give you a quick idea of what we're working with. There's the level converter and the interface, and there's our WRT. It's a little bit messy. We can definitely clean this up. In fact, in some later point in time, I do in fact plan on putting a few headphone jacks about here and here, so I can easily interface into the dual serial port using the headphone jack method. I can just plug right in and access the serial ports, and these serial ports will allow us to have a root shell access or a shell access, and we can do command line Linuxy stuff, which we'll probably get into later episodes. Okay, the first thing you need to know exactly is where your USB to serial adapter or your serial port resides. Now, the USB serial port COM13 is my FTDI, which is going to be hooked up to the Linksys. In a little bit, I'm actually going to show you the prolific USB to serial communication port, which is hooked to COM2. You need to know these. Now, we've got Hyperterminal, which is one of the most commonly used applications. This is comes in everything from Windows 95 all the way up to Windows XP. There are other applications such as COM Plus or EmuTerm. I'll put a whole bunch of different serial terminal applications. Now, the terminals also have to have terminal emulation types like VT100 and things of the such. We'll get into that later. So we're going to create a new connection, and we're going to name this, well, what was our prolific on? Prolific was COM2, sorry. So we want to set this to COM13. We'll name this COM13. Now, we want to go directly to COM13, and it's asking us for the speed, data bits, parity, stop bits, and the flow control. Now, when connecting to certain devices, it's usually by default either 11.5K, 57.6, or 9600. I know for a fact when communicating with a WRT, a FOD, or many other embedded devices, it's usually 11.5K, so we're going to hit apply, we're going to click OK. And the button up here is the call button, which we know that we're already in a call, and we are going to power up the WRT. And notice how instantly we're getting a whole bunch of technical information. This is actually the bootloader, and it's literally, it's the BIOS screen. This is actually Red Boot in its process of actually booting up the WRT. Now, this should be running DDWRT version 24 RC something or other. So it's going to go through the boot process, and it'll eventually dump us into a command prompt where we can log in, and then using this as quite literally a secure shell, in essence, just no real security session. Now, if you notice at the bottom of hyperterminal here, it tells you how long that you've been connected, what type of protocol it's using, its speed, parity, data bits, stop bits, whether or not you have local echo enabled, whether you have screen capture, numlock, caps, and scroll lock. Now, while this is going through its thing, I'll explain a few other things. Now, you can actually transfer, send and receive file by using different protocols. Now, this I don't think is supported by DDWRT, but if you actually send a file, you can use different protocols such as Z modem, Y modem, Kermit. The most common is Z modem with crash recovery. But, like I said, really don't think that this is supported by DDWRT. But if you were to connect two computers together, which is what I used to do back in the very old days before even I had networking, to get a file from one computer to another, I'd hook up a null modem, and I would use Z modem with crash recovery. Okay, there we go. We're at the DDWRT login. You can log in as root. And here we are, DDWRT version 24. No IW config, let's see, ls, where are we, cd, and we can use the typical Linux commands. And if you notice, it's actually using color codes, meaning that it's actually, notice how the terminal emulation actually changed from NZW. Now, of course, like I said, I'll put more about it in the show notes of terminal emulation like VT100, VT102, etc., etc. Alrighty, well, we're going to move on to the next step, and the next program I'd like to showcase is SerialMon. You know what? Before we even move on to SerialMon, later versions of PuTTY, the secure shell client for many operating systems, has the serial capabilities. Just make sure you put in the proper communication protocol. 115.200. Now you can go to the serial tab down here. Make sure you have proper flow control. Click open. Will it give us a shell? There we go. Not much more to say about that. PuTTY can also be used to directly communicate with your serial port. Alright, off to SerialMon. SerialMon is an application that allows you to sniff serial communication going across a bus. Now, you can actually use the equivalent of a beige box, basically a serial port connector with a couple of wires and alligator clips spliced into the lines, and, well, of course, you probably need a level converter for this. But you can use this application to sniff serial traffic. Now, the first thing you need to do is actually set up your port. Now, we're going to be using the Prolific USB, which is hooked up to my Pro 95 radio scanner, which has a programming cable attached to it. Now, it actually has different types of connections, whether you want to actually sniff a direct connection to a device, line monitoring using unidirectional, meaning the transmit and receive are physically connected, line monitor, meaning that you're using actually a diode and a resistor, and you're only really using one transmit line on the PC side, a man-in-the-middle attack, or a bidirectional full duplex attack, or software monitoring, meaning you've got a program hooked up to your computer and you're pretty much just going to sniff it that way. Okay, so here we have it going, and we're going to get it recording, and we're going to bring up my Pro 95 radio scanner software, and we're going to turn on my scanner real quick, because it won't work unless the scanner's on. And we're going to download from the scanner, and it's going to be reading the data, and we'll go back to SerialMon and look at all of this yummy, juicy data that's going by. Now, you can actually parse this into different frames, whether it be in plain text, hex, or ASCII codes. and you can actually put it into frames, whether it be RP570, SPA bus, or NMEA0183, also known as GPS data. But because this uses a custom protocol, I would look at this in hex. And as this flashes by, you can probably notice that there's actually a lot of similarities in the data frames themselves. This can all be very useful into reverse engineering the communication protocol layer between a serial device, or back in my day they actually used serial port security dongles, where software would not work unless you actually plugged in a specific dongle that had a type of header, so to speak, so that software would communicate via the serial port, and it would the software wouldn't work without it. Alright, now we're going to get the Win95 to stop. Alright, you're probably saying to yourself, Fox, I don't have any of this really fun, handy-dandy hardware to play with. Give me something easy. Well, if you have a laptop with a built-in modem or even a PC, chances are it's actually on COM3. So let's go ahead and open up PuTTY or whatever terminal you plan on using. We're going to hit open, we're going to get this in frame real quick, and we're going to go to SerialMon, and we're going to tell its preferences to hit down to COM3 and record the data. We're going to go in, and you can actually, I'll put this up in the show notes as well, put in some Hayes compatible modem commands, ATTT, attention dial tone. And of course, Windows pops up, no telephone signal detected. Alright, so how about ATZ, reset? Okay, that's fine. Now we go back into SerialMon. Notice how it's actually pulling up all of the data that's going to cross that serial port to the modem. Alright, there you go. Just a brief introduction to serial communications and what you can do with a serial port and hardware. Now, serial ports are not just dedicated to just a laptop. You can also do this with PDAs, some smartphones, some toys have serial ports. We're going to be doing some really cool stuff with serial terminals and embedded hardware in later segments. So I'll put a lot more in the show notes. I'm running out of time here. So as always, you can catch me on IRC. Check the show notes for more information and more links to information pertaining to serial communications, serial ports, and so forth. Alright, hope you learned something, and I hope a few gears in your head are clicking. I hope I got a few of you thinking about some of the stuff that we might be leading into.
I guess the first thing to demonstrate is Google Maps that's built into the that's built into the G1. If you just click on the maps on the desktop, it'll load up Google Maps, and there's some interesting features. For example, if you hit the menu button, you can go to search. Well, let's see. First, you want to go to My Location, so it will discover where you're at. Once it discovers where you're at, you can search for things in the area. I hit the menu button, go to search, and for example, I'm looking for pizza. So, I hate this on-screen keyboard. Yeah, fuck it. Open it up. So we're looking for pizza, and it will search for pizza places in the area. Now, as you see, it's got a list of different pizza places in the area. Just click on whichever one you want. It'll show you right where on the map it's at. If you click on it, it'll have the phone number where you can call it. It'll give you directions to the address where you're at from there. And you can even, with some places, you can go right to their website. Like, for example, this pizza place you can order online. So I can pull up their menu on the phone and actually see what they have for sale and make my order right through the internet. Directions to this address and just my location, and it shows where the pizza place is. Click route. And it tells me how to get there. Can't be much simpler than that. That's a really good application. Like I said, it comes built right into the phone, so this isn't even something you need to download. This next application is called GeoBeagle. It's used for geocaching. If you don't know what geocaching is, you should definitely go back a couple segments and watch Ugster's segment. I think he really covered it pretty well. Or just Google it. But anyway, this has two different geocaching sites built into it. You can select the service provider. Personally, I like the Atlas Quest letterbox one better. Of course, this phone's fighting with me. But anyway, go online and it'll give you a list of different geocaches in your area. Depending on your internet connection, it might take a little while, so be patient. Okay, so it's got a list of results in the area. The first one is in Millville, New Jersey, which is about 10 miles away from me. So we're going to select that cache. Okay, and now that that's loaded up, it tells you who started the cache, the address of where it is. You can get MapQuest information, stuff like that. What else? Repairs needed. Details. Yeah. You can go to view the clue, so it'll give you a clue of where to go look at. And when you're done, you can record that you found it, print out information and other information. It's a pretty neat application. There's more features in it. I haven't played with it too much, but it's got very high reviews, and it looks like it's got some potential. So if you're into geocaching, give this a try and see if you like it. This next application is called GPS Measure. Basically what it is you start up the application and you mark your start point. And now I can walk, let's say I take the phone and walk to my car. And when I get to my car, I just hit the end point and it'll show how far it is. So I'm going to pause this tape and I'm going to walk to my car and we'll come back. And I'm back. And as you can see, the walk to my car is 38 meters, I think it is. As you can see, it doesn't show the direct path because the path to my car winds and turns a little bit. It actually shows you the distance the way the crow flies. So this could be useful for you. I don't know, give it a try, see if you like it. This next application is called GeoGraffiti. Let's load that up. And what this is basically you can mark an area you're at via the GPS coordinations. You'll need to sign up through their website and sign in. And what you can do, like where I'm at right now, is a good fishing location. So I can voice mark this location, and of course when I'm logged in, I don't have an account with them, so I can't. But I can mention, okay, there's good fish back here, or you know, there's some trees in the water right behind me, so don't cast out to the left because you'll snag. And when people have an Android phone and they're running this application, when they come to this location, they'll hear whatever I voice marked. In my area, I think I'm one of the only people with a G1, so it's not too useful, but if you're up in the city somewhere, it could be interesting to walk around and just see what you find. I mean, we all like walking around and we're driving and scanning for different things. Why not have the Android going and see what else that we can find hidden digitally in amongst our world. Okay, this isn't exactly a GPS application, more it takes advantage of the compass in the G1, but this is like the flight control on an airplane. I find this useful because I go off-road in my Jeep a lot. Not only does it show you the direction that you're going, but it shows you the pitch and how far forward or backwards you're leaning. This comes handy, like I said, I go off-road in my Jeep a lot, so it comes handy to tell exactly how much my Jeep's leaning, so I know right before it's about to flip over. It's an interesting application. I really don't use it all that much, but I figured I'd add it in case anyone was interested. This next application is called Orientator. It's a basic, simple to use compass for the G1. Very simple, but kind of accurate. Not the most accurate, but pretty good. What I use it for is testing out the compass in the G1. A lot of G1 cases that come out now have a magnetic clip to keep them shut, which is stupid. Whether you have a G1, an iPhone, or any kind of smartphone that has a compass in it, you don't want a magnetic case because it'll burn out the compass inside. What I did was I just cut out the magnet and replaced it with Velcro. But if you do happen to have your phone near one of them, or you have a feeling that your compass isn't working right, because there's a lot of applications that use it, you might want to download this program and give it a shot just to see if your compass reacts to movement. Anyway, on to the next segment. Another great application for locating your lost Android is called Where's My Android? This isn't as good as SIM Checker in my opinion, but it's good to have installed with it. Basically with this, you can set an attention word and you can SMS your phone and tell it to either turn on the ringer, because of course you lose your phone. Every time you lose your phone, it's when it's on vibrate. So you can SMS it an attention word and it'll turn the ringer on, it'll turn it all the way up, and you can set different intervals. You can have it ring for 30 seconds, have it ring for 60 seconds, or 5 minutes straight. So that gives you some time to dig through the couch, see if you can find your phone. There's also the function for an attention word for the GPS. So you can SMS it and tell it, hey, turn on the GPS and send me the location of where I dropped my phone at. Ideally, that's a good function, but I think it's poorly implemented in this. One of the problems with it is you have to keep the GPS enabled for this to work. It will not enable the GPS itself, unlike how SIM Checker does. So if you have the GPS turned off, this does no good. Now, the reason why I say that sucks is because if you do keep your GPS turned on, by the time you realize that you've lost your phone, your battery's already dead, and this will do you no good. In future versions, they're supposed to fix it to where it can turn the GPS on for you. I'm not holding my breath, but hopefully they do fix it. Anyway, install this. I definitely recommend installing this and installing SIM Checker. Neither one of them take up much memory, and they're very good applications to have, especially with a phone this expensive and that holds this much of your personal information in it. This next application is called SIM Checker. This is definitely a must-have application. Basically, once you install it on your phone, you type in a phone number that you want it to SMS, and you type in an email address. And then if somebody steals your phone and you cancel your account and they put their SIM card in your phone, it'll automatically turn on the GPS and it'll start SMSing you and emailing you the location where your phone's located at the time. It's a really good application. After I'm done recording this, I'll pull the SIM out of one of my other phones and put it on there, and I'll put up the email on the screen so you see what it looks like, how it locates you. You can set different intervals about how often you want it to message you, letting you know whether it's every 5 minutes, every 2 minutes, I think, or whatnot. Like I said, this is a really good application. It'll probably help you get your phone back if your phone's stolen. When you put somebody else's SIM card in it, nothing even pops up on the screen, so people don't even know that it's tracking them. So give it a try. Definitely install this. If you have a G1, install this on your phone. It doesn't take up much memory, and it's well worth having. This next application is called Locale. This is a great application. As I mentioned before in previous Android segments, I mentioned an application called Power Manager. Well, they never decided to come out, as far as I know, they never decided to come out with an update once Cupcake was available, so you can't use that program anymore. With this application, you can actually set different scenarios in your phone based on your GPS location. So, for example, when you get home, if your GPS detects that you're at your house, it'll turn your Wi-Fi on, it'll turn your GPS off. When you go to work, when you step into work, you can set it so that it puts your ringtone on vibrate instead of the obnoxious ringer that you have. You can set it so different time scenarios. So, for example, during the day, your screen brightness is turned all the way down to save on your battery, and at night it turns up, or vice versa. It's a handy little application. There's a ton of different settings that you can set in here and different scenarios. I really suggest, I can't show you all the features on this short segment. I really suggest this is one you should download and try for yourself. It's a must-have application, and it's free. I mean, they accept donations. I think pretty much all these applications I'm showing are free.
As you can see in front of me, I've got my radio, SWR meter, and a bunch of pipes and shit. So apparently we're doing some antenna design. Today we're going to be doing the J-pole antenna, also known as the Zepp or Zeppelin antenna. That name was actually comprised because this is what the Germans and the Nazis used on the ass end of Zeppelins back in World War II. Now, a J-pole antenna is, well, looks like a big letter J. Now, this is actually a half-wave dipole. It's just kind of bent and contorted. Now, this side is actually half wavelength, and then this is 1/4 wavelength, as well as this side is 1/4 wavelength. Now, the gap between it, all of this, with any antenna has to be mathematically calculated. Now, I'm going to focus mainly on the 440 megahertz ham radio band, primarily because a couple of episodes ago I went into how to modify FRS radios to have an antenna jack, which fall very close to the amateur radio 70 centimeter band for 440 megahertz. Also, a 2-meter J-pole antenna would be quite large, close to 6 feet or so tall, which I just can't fit in my framing of my living room. Okay, so in front of me I've got a couple of J-poles. I've got my SWR meter, my ham radio, and I've got my computer. We're going to go to the computer side real quick, and we'll do a little bit of explanation of actually how to calculate the dimensions of a J-pole and get a little bit more understanding of how it works. Okay, by doing a quick Google search of J-pole antenna, we come to one of many websites. All websites will be in the show notes, so check the forums for all of the URLs. Here are the calculations to actually design a J-pole antenna in general. Now, the long element denoted in this image as A is 705 divided by a frequency in megahertz. That will equal your feet. Now, this is from the tip to tip, where I'm pointing with my cursor, is actually half wave, and then the rest of it will be full wave. So usually that's close to a full wave. But depending on your standing wave ratio and your feed point, that can differ. Now, this second element here, that's denoted as B, that is the secondary element, which is 234 divided by the frequency in megahertz to equal the feed. C is 23 divided by F in megahertz to equal your feet. And this is the where you actually place your feed point, your connector or your coax. This is the distance from this tiny little nubbin down here, which is denoted as D. The D is the space between the long element and the short element, which is 22 divided by frequency in megahertz to equal the feet. If you scroll down in this page, it goes into a little bit more explanations where you can explicitly design your antenna with their online calculator. So let's say we wanted to do this for amateur radio 440 megahertz. We type in 440, and we calculate the antenna would be 19.2 inches long. It will be the short section is 6.36 inches. The feed point is 0.6 inches apart, the 6.6 inches above the actual spacing, which is 0.6 inches. This is a very good website, and it actually designs J-poles very, very well. The next one to look at is actually called the Emergency Ladder Line J-pole Antenna. This is a PDF file. I will actually link to the hosting website. Basically, this actually gives dimensions on how to design different ladder line J-poles or twin lead J-poles that are denoted for specific ham radio bands. No calculator here, just pre-built mathematical calculations. Now, I'll show you in a moment why these actually have a benefit and a drawback, but the main benefit is they don't take up much space, and you can roll them up and put them into a very short space. You don't need any copper or metal pipe. The ladder line is very flexible. This website here goes through a relatively in-detailed process of how to actually build a 2-meter J-pole, which pretty much goes through the same calculations that we showed on the first website. Also, explains compensating for using PVC connectors and T-fittings, which I'll show you in a moment, and explains how to actually sweat pipes together using using a propane tank, flux, as well as everyday Joe Schmo solder. I'll get into a little bit more about sweating pipes together in a minute, but I'm not going to show you the in-detailed process. It's pretty straightforward. Once you get a little bit of experience, you'll get the hang of it. Alright, so by now you have an understanding that the J-pole is actually an omnidirectional antenna. It's half wave, relatively easy to construct depending on your materials. Now I chose copper pipe because the thicker the material, the more power output it can handle. So something like this can handle probably close to 100 watts of power output. If you use something very thin, which I'll get a close-up in a moment of, you know, something like 16 gauge wire, I really wouldn't go over anything about 10 watts. But if you're going to be using this on FRS radios, pretty much 20 gauge or 22 gauge copper wire, because FRS radios will not be going over, say, half a watt of power output. But either way, let me re-angle the camera and I'll give you a close-up shot of how I actually put these together, and then we'll do a couple of SWR tests on these different J-poles. For this J-pole, which is tuned to about 460 megahertz, what I did was I pretty much just sweat the appropriate connectors together, compensating for the bend radius of the T connector as well as the 90-degree angle elbow. I'm using a panel mount end connector, which is left over from our Wi-Fi series, and then I took some, I think this is 16 gauge copper wire, and I coiled it around a few times, and then attached it to the feed point per the instructions of creating a J-pole antenna, and I put spiffy little end caps. I didn't actually solder these on. I didn't feel that this was a necessary step at this point, as these will not be put outdoors as of right now. Plus, if you actually want to adjust your SWR, you can shave down the ends and adjust your SWR. You can also adjust your SWR by actually moving this up and down the actual necks. Now, the reason I also used a what's called a pipe hanger. This is a copper strap used to hold copper pipes to your ceiling. I wanted to use two of them, but it's really hard using two of them in a design like this. So basically the idea of this was I was able to move this entire section up and down until I got the SWR that I liked, and then I pretty much soldered it all in place. Now I used the T connector, but this isn't 100% necessary. But, you know, the catch-20, I mean, you don't need to have any kind of length of antenna going in this general direction. This is just for mounting, so I pretty much have a spare piece of copper pipe. This will not affect the gain of the antenna whatsoever. That'll just fit in like so, and you can mount your J-pole antenna horizontally or vertically. Vertical is pretty much ideal. Now, one thing I did want to mention, though, is that, you know, when you're working with certain ham radio antennas, you know, things have a tendency of getting to be quite large, especially when you're dealing with 2 meters and 6 meter, 10 meter, etc., etc. So they've actually got these threaded fittings for copper pipe, which you'll be seeing me use on other antenna types that can thread together. Now, this will actually make it so you can break your antenna down to be relatively portable instead of having one huge honky-donkey dick of an antenna. Now, if you are going to be designing this antenna for something that's going to be excessively large, and you want it to be something that you can either throw in the trunk of your car or inside of a backpack or a small bag, use these threaded adapters. Just remember that these threaded adapters will elongate the size of the copper pipe, so you will have to go and cut the tips of your pipes down a little bit smaller. Your best bet is to actually sweat solder your connectors on where you like them, and then cut your thread them in, not as tight as you can, just by hand tightening it, and then cut it down to the exact size you need. But we're working with lower frequencies, so it's much more forgiving when it comes to being off measurement. Now, here's the ladder line, or what they call twin lead. It's literally just twin lead. What you need to do is, per instructions, is first, you know, let me zoom in a little bit so you guys can see this, because this is a bit, where am I on frame? Okay, now, according to the instructions, the first thing you need to do is actually solder and bridge the bottom over here. Now, a 1/4 inch on the instructions, it says anything on the 440 megahertz band. You need to make a notch and strip away to the bare copper so we can have our feed point. Now, you're not supposed to be using a connector like this. You're supposed to directly solder your coax in, but I didn't have anything that'll actually fit on my SWR meter at the moment. Then, X amount of inches up, on this case it was 5 inches up, you need to actually break the copper away from the twin lead right here. So there's actually a 1/4 inch notch that's just been completely ripped away. And then about 12 inches of ladder line or twin lead, depending on what your region calls it. To adjust the SWR, what you can do is you can slowly nip away at the length of the end of this until you finally actually tune into the frequency that you want. This will work on damn near any frequency. To hang this antenna, you put a little hole right here in the tip and you hang it by non-conductive material like nylon string, fishing line. Just don't use copper wire. And you pretty much just hang the thing up like so it actually hangs in a straight line. And like I said, with these ladder line J-poles, they don't take up nearly as much space. I can fit this entire thing in my pocket, and then when I'm on site, unroll it, good to go. Alright, first antenna I'm going to do an SWR test on is the copper J-pole. Now, got my connector, I'm going to plug this in. Now, what Ophidian failed to mention, unfortunately, in his SWR segment, is that SWR meters need a minimum of 1 watt of power output to function properly. And another thing about these J-pole antennas, you really don't want to have any metal or human beings within about 2 or 3 feet of them, otherwise they'll actually throw the SWR ratings off. Now I'm just going to turn my radio on real quick, and I'm going to lock the backlight on for you so we can see, and we're going to take our power output down to a legal FRS limit. Now hopefully we can see, as I transmit, this should give off a pretty decent SWR. Now if you notice, we're doing about 1.1 to 1 SWR, which is pretty good. Anything above, I'd say 1.5, you're getting kind of suicidal with your antenna. Now we're going to go to a higher frequency on the FRS list. Go to FRS channel 14. This is actually going to give us a lot more SWR. Now I can't really read my camera all too well, but you know what, let me look at this real quick. Actually, that's giving us better SWR. Huh, I'll be damned. Alright, let's knock this down to FRS channel 1. Shut up. Alright, FRS channel 1. Oh yeah. FRS channel 1. It's giving us 1 point... Wait a minute, I'm still transmitting at freaking 5 watts here. Ah, that's not so bad. It's about 1.5 to 1, so that ain't so bad. This goes to show that this antenna is tuned for roughly the FRS frequencies. It'll give you omnidirectional capabilities with a fair amount of gain. I can't tell you exactly how much, I don't know, but it'll definitely beat the pants off of whatever crap antenna that you've already got on your radio. Let's go out and switch to this ladder line antenna real quick. So we're just going to take this, that pulls off. Now, I am actually going through a lot of gender benders, and I'm going through a lot of different coaxial types, which is throwing the SWR off. So whenever you're actually building this, you make sure that you're taking your SWR, your coaxial cable into accompaniment when dealing with the SWR. So now I'm just going to sit here and hold this. It really should be suspended by a non-metallic and a non-conductive thing. Let me see what the SWR on channel 1 is. Alright, here, let me show you guys. It's about 1.1 to 1. You know what, and every time I transmit, my camera goes kind of wonky. Huh. Weird. Alright, let's bump this up to FRS channel 6 and see what the... Let's see what the transmit power is. Or sorry, the SWR. Wow. If you go ahead and look at this, it's almost 1 to 1. Which means the SWR on this is almost perfect. Alright, we'll bump this up to FRS channel 14. Yeah, this ladder line antenna. Hope you guys can actually see that, because those needles are kind of fine, but if you can't, take my word for it. This is actually working pretty good. Now let's go down to a quick 70 centimeter ham radio band. Give me 1 second to tune this in. I'm going the wrong freaking way. Where are you? There we go. Alright. Now let's actually turn down my transmit power, just in case the SWR is that high, we won't blow out the radio. Yee, Jesus Christ. It's actually doing 1.2 to 1. Or sorry, 2 to 1. At least we're hitting the repeater. Well, alright, gonna crouch down real quick, do a recap. Alright, so there's J-pole antennas, both ladder line as well as copper. You can use copper wire, copper pipe. The thicker your gauge wire, the thicker the gauge wire or your pipe, the more power output you can push. With these little itty-bitty ladder lines, wouldn't go really above 10 watts maximum. I tell you the truth, I would push 5 watts and wouldn't even risk it above that. Now you can make these for practically any frequency. They are very easy to construct, as you can see. If you need any more help in construction tips or techniques, or generally understanding how they work, you can always hit me on the IRC, or you can go and check out the show notes. I'll have more information, links, URLs, and possibly even pictures of some of the crap that I've designed. So, that's that. Bugger off.
Alright. I got my buddy Nix here, and he's going to show us some HTC Touch Pro stuff. Now, some of you may or may not know, but HTC, the high-tech computer corporation based in Taiwan?
Yeah, Taiwan.
They originally started making things like PDAs, now they're making phones and whatnot. They're extremely hackable. My Dell Axum that I've showcased on the show a while back was actually made by HTC, but unfortunately, because it's Dell owned, there's a non-disclosure agreement, and there's not much you can do with it, but we may or may not have showed some Dell Axum hacks. But Nix, why don't you get into some of the stuff you can do with an HTC Touch?
Alright, I recently got an HTC Touch Pro from Verizon Wireless, my carrier. It's a CDMA phone. With the HTC Touch Pro and with just about any HTC branded phone, you can the biggest thing is you can replace the ROM. You can replace the operating system on the phone with a custom one.
Windows Mobile.
Yes, Windows Mobile.
Some of them will run Linux, but that's a completely different thing.
Yeah. This one runs Windows Mobile 6.1. They have some that run 6.0, some that run 5.0.
Yeah, my original Dell Axum X51V originally runs Windows Mobile 5, which, if you've watched previous segments in previous episodes, is balls horrible, because HTC releases their ROM update utility, which is the gateway in hacking HTC devices. The ROM update utility allows you to hack the device, or upgrade, or cook your own ROM, whatever you want to call it. Now, because my Axum is non-disclosure agreement, I don't have the ROM update utility. But the HTC phones, the Touch Pro, the Diamond, the Wizard, the Titan, anything by HTC for that matter,
right,
you can do some pretty crazy stuff with. You can literally, to some phones, especially the Touch Pro, Touch Diamond, Wizard, etc., literally build your operating system from the ground level up how you want it. So Nix is going to go into some of the stuff that he's done with his phone recently.
Yeah.
What have you done?
Well, I just got this phone a few days ago, and jumped on some forums. There's a few websites you should check out if you're interested in doing this yourself. ppcgeeks.com has some great information. XDA developers, and also HTC Geeks. There's ROM developers on the forums. They release their own ROMs, and for download, you can install them on your phone. I tested out several before settling on which one I wanted to run on my phone.
Which one did you go with?
I went with a ROM by Scott Krosler off of ppcgeeks.com. He actually hosts it on he hosts his ROMs on his own website, scottkrosler.com. but I found out about him through PPC Geeks on their forums.
What made you settle with his ROM over anyone else's?
Well, he was one of the first to provide a ROM built off of the stock Verizon ROM that included a fix for the AGPS access.
AGPS.
Yeah, AGPS, yes.
AGPS is, for those of us who
Okay.
don't know,
Assisted GPS. If you know anything about how GPS works, you acquire the satellites and triangulate your position. AGPS is available on a lot of CDMA cell phones, and it uses the data network on the cell phone carrier to download satellite information so that the GPS antenna on the phone knows which satellites to look for. Now, Verizon Wireless locked that down. They locked that down so that you had to be able to use the enhanced GPS services. You had to pay $10 a month for their VZ Navigator software. With this fix, you're able to use Google Maps, Live Search, any other GPS software.
will the AGPS also give you a faster lock when using war driving programs like Wi-Fi Phone?
Yes, yeah, it will. I can walk outside right now, get a GPS fix in under 30 seconds.
Okay, now, the actual ROMs are built off of stock ROMs.
Right.
Could this actually potentially be illegal, DMCA, copy protection, because in Germany and all that, they've got some pretty crazy anti-hacking laws now, unfortunately. Would be using one of these on your phone in another country potentially be a crime?
Yeah.
Maybe, maybe not. So
maybe
you might
not.
want to look out for that.
Yeah. Now, also keep in mind that with doing this, you could always potentially break your phone. There's always that risk.
Yeah. So, accidental insurance. We've been pushing that since episode 1. Can't stress it enough. But a catch-22 is you have to revert your phone back to its original firmware, your original OS. Now, the ROM, or the read-only memory, is where the operating system is contained. Now, you were when I was I've got an HTC Wizard, which is a much older version of one of these, and I've noticed with those there's the IPL and the SPL.
Right. The IPL is the initial program loader that's installed by the carrier, and you're not going to ever do anything with that. That's like the BIOS on the phone. If you fuck with that, you'd probably brick your phone. Now, the SPL secondary program loader is called up by the IPL, and that's what boots your operating system. To replace the ROM, to hack the phone, the first step you do is to replace the carrier's SPL with a hacked SPL, an unlocked version that allows you to update the read-only memory.
Okay. Now, what are the chances of actually bricking? Because I mean, there were a couple of times when Nix was flashing his phone, I noticed that there was communication errors. Now, normally when we do this for the Touch Pro, we were doing it through ActiveSync, but if you do not have Windows, you have Linux, you can do this from SD card. Because
Yes.
I could do that with my AXA.
Yes.
And with the HTC Wizard.
Yeah, there's two methods to flash it. Either you put the new ROM on the SD card and use a utility on the phone itself
Okay.
to update it, or you can go through ActiveSync 4.5. That's what I've been doing. It's a very easy process. You just run the ROM update utility and follow the steps on the screen.
Yeah. You're going to go and cover the through ActiveSync.
Yes,
Today.
that's what I'm going to show.
So, I really don't know what much more to say. I mean, there are a whole bunch of things that you can do with these phones besides just a lot of people are like, oh, I'm going to flash it with something new just because, and they can't fill in that blank. And I mean, you can unlock the AGPS. You know, a lot of people complain that the keyboard lag on that was really shitty.
Yeah, there is noticeable lag on the keyboard, on the hardware keyboard when you're typing text messages or Word documents or whatever. There are ROMs out there that correct this issue. You get a lot faster key press.
Oh, you know, it's something that also just came to mind. Nix's carrier, Verizon, which completely sucks balls when it comes to contracts and whatnot and their bureaucratic bullshit. It turns out that if you install any software whatsoever, even if you don't flash it, let's say you put Wi-Fi faux thumb on there, or any of the other software that we've covered in previous segments, it voids your warranty. And that's complete bullshit. I mean, so make sure you actually read the fine print of what you're allowed to put on your phone. Because the fact that you have a Windows mobile device and you're not allowed to put on Windows mobile software is complete bullshit.
Yeah, definitely check that.
Yeah.
And if you do return the phone for any reason, I'll cover it later on. How to revert the phone back to the stock firmware, which is available for download on forums for PPC geeks.
All right.
Yeah.
All right. Sounds good. So we'll get to the
Let's flash the phone.
flash phone.
Okay, now we're going to flash my phone with a custom ROM. First thing we have to do though is unlock it. On CDMA phones you have to install a hard SPL, secondary program loader. With GSM phones there's something to do with SIM unlocking phones. I'm doing just with CDMA because that's what I got. First we're going to put the phone into bootloader mode. Alright, we're in bootloader mode now. You can see that lists versions of certain software on the phone, including our SPL. I'm going to run this utility here, which will install an unlocked version so that we can flash the phone with a custom ROM. This is a vital first step whenever you're going to flash a phone with your own custom ROM. If you don't do this, if you go straight to a ROM, you just may break your phone. You can find a lot of information on how to do this on several websites. ppcgeeks.com, htcgeeks.com, and xdadevelopers.com are great resources for HTC devices, not just their phones. You can find tutorials as well as custom ROMs that people have built and uploaded to the site. Okay, now that the phone's unlocked, we're going to install custom firmware. I selected this one made by Scott Krosler. I got it from ppcgeeks.com. Main reason for me selecting this one is it's based off of the stock Verizon firmware, so that I don't have any Sprint labeling or anything in that like that in the menus. It also has the highest compatibility with my hardware. To install the firmware, we're going to run the ROM update utility he included in the package. His ROM also includes a fix for GPS, for AGPS, that was made by Board, also on the forums. It allows me to use Google Maps or MSN Live Search or any other GPS software on the phone so that I don't have to rely on Verizon Wireless's VZ Navigator, which is a pay service. I can use Google Maps for GPS navigation for free. He's also tweaked the ROM so that it loads faster than the stock ROM, and added some nice programs to it. Okay, so now we've got my phone here with our flashed ROM, and we're going to revert back to the stock. Reason for doing this: if you ever have to return it to your carrier to get a replacement, they'll want to, when they turn it on, they'll want to not see a custom boot up or anything like that. We begin with active sync connection to the phone. And on my phone it's real simple. I just have to run this one application that you can download from PPC Geeks. It's going to use the ROM update utility and install the stock Verizon firmware. Alright, and like before, the RUU is going to put the phone into bootloader mode for us. And install the old firmware. Alright. After the update, the phone's going to reboot with the stock firmware on it. After that's done, we're going to manually put it into bootloader mode and relock it using this utility, also from PPC Geeks. This will remove the hard SPL that we put on before and put the stock Verizon SPL back on the phone. Alright, and we're in bootloader mode, and I'm going to run the relocker. And that's it. When the phone boots up again, we're going to put it back in bootloader mode to show the version changed on the SPL. There you have it. After you do this, you can ship it off to your carrier for replacement if anything should ever go wrong.
All right, you're a ham radio operator, correct?
That's correct.
All right, what bit you in the ass about ham radio?
Well, the idea that you can carry an HT wherever you go, and you're always in contact with someone. I'll give you a little story. About 5 years ago, I suffered a heart problem. And I was walking in the deserted part of Staten Island. Didn't have a cell phone, but all I had was my HT. I got on my HT, I called for help. Within minutes, local clubs came to my assistance, notified 911, and I was saved. And this actually happened to me 2 times as an amateur radio operator. So that's why I hold amateur radio very dear to me.
Amateur radio literally saved your life.
It saved my life. I would not be here today talking into this device if it wasn't for amateur radio.
Well, what actually got you into actual amateur radio to begin with?
Well, I've been into CB radio all my life since a kid. And then eventually someone talked to me about amateur radio. I took classes at the KCRA, became a novice, went into tech, became an extra, and that's where I stand now, an extra class operator. And that's it. I just enjoy the hobby, and it serves a useful purpose.
Well, what kind of hobbies do you do with you personally? What kind of stuff do you enjoy about ham radio?
Ham radio, just getting together with fellow hams. Sharing the day such as today at field day, and getting together just even for a cup of coffee. That's what I enjoy.
All right, do you prefer any specific bands over any others?
I work mostly VHF and UHF.
All right. You don't do any of the digital stuff?
No, I don't.
How come?
I guess everyone has a niche in amateur radio. There's something for everyone in amateur radio. You have the HF, VHF, UHF, slow scan TV, RIDI.
Radio TTY, you got D-Star, packet mode.
So many different aspects of amateur radio. And this is what I enjoy to do. Talk locally on our repeaters.
Well, what about globally? Do anything global? Talk to other continents, other states?
Well, years ago I used to work 10 meters. I pretty much spoke all around the world, made a lot of contacts, got a lot of USO cards. Basically, that's it.
That's pretty cool. How long have you been a ham?
Since 1991.
Wow, Jesus Christ, you've been a ham as long as I've been alive.
1991.
91, I'm sorry, I thought you said 81.
No.
I thought you said 81. Like, wow, Jesus Christ, you've been a ham for fucking almost 28 years.
You got a good profile?
You don't have a good profile. I love you, man. All right, thanks.
See you soon.